So, hello everyone. Let's start with another problem which is known as perfect number. So, first of all, what is perfect number? A perfect number is a positive integer that is equal to the sum of its positive divisors, excluding the number itself. So, let's take an example. Let's take first example like num is equals to 28. And if we see clearly in the first example that 28 is divisible by 1, of course. 2 gives 14, 4 gives 12, 7 3 times, sorry 4 times, and 14 2 times, right? And if we sum these all together, 1 plus 2 plus 4 plus 7 plus 14, we'll get 28, which is equals to the num, right? That means this number is perfect number. Hence, we'll return true. What could be the logic? Logic would be very simple, that we use a for loop, and from 1 to n, or to be more precise, from 1 to n divided by 2, half times only, because we do not have to include the number itself, correct? We'll make a loop till that, and we'll check whether each number is divisible by the num itself or not. If it is properly divisible by num, then we'll add into a sum, and at last we'll check whether sum is equals to num or not. If it is equal, then we'll return true, otherwise we'll return false. Here is a catch. What we can do, instead of including 1 in the for loop, we can exclude 1 and start our loop from 2, and we can make the value of sum equals to 1, correct? So let's start. First, we'll divide our num by 2 so that we can get the half value, and our loop would be reduced half times. Okay, then we'll take sum, we'll take it equals to 1 because we are excluding 1 from our for loop. Now we'll start loop from 2 to and divide by 2, that is p, including p itself. Now we'll check the condition that if num mod I is equals to 0, then sum plus equals to I. And if sum is equals to the num, then we'll return true, otherwise we'll return false, correct? Now what could be the time and space complexity? Very simple. We are looping from 1 to, or you can say 2 to n by 2. So time complexity is big O of n by 2, which is equals to big O of n only. And space complexity is constant because we are using sum, p and I to allocate different memories in it, right? That's it. Let's try to run it. For 28 it is giving true, and for 7 it is giving false, correct? Let's try to submit it. For num equals to 1, okay, we can include a base case that if num is equals to 1, return true, correct? And this base case could be included above only. Now let's try to run it. This is the only thing which is not passing here. If Oh, sorry. We have to return false, not true, right? My mistake, sorry. Now let's submit it. This is the only case which is not running, okay? If we'll submit it, yeah, it is running absolutely fine. This could become a base case if we start our loop from 2, correct? That's it. Signing off. Bye bye. See you tomorrow.